Hey students, today we're going to be solving for missing angles in right triangles. And to do this, we're going to have to use our trig functions, sine, cosine, and tangent. So if you haven't seen the prior videos that I've made about this, please pause and go back and watch them because this is going to be referencing them a lot today. So you might see a question like this one: what is theta? Round your answer to the nearest tenth. And theta is a missing angle in a triangle, and we can use our trig functions to figure this out. So since theta, the angle down here, is the one that we're trying to find, we want to set up an equation that involves theta and the other information in the triangle that's given to us. So we have 7.7, which is the opposite side of the triangle. We have the 14, which is adjacent to angle B. And the side that we don't know is the hypotenuse. But referencing SOHCAHTOA, we want to pick a trig function that is going to involve the two pieces of information that we already have, which is opposite and adjacent, which means we're going to be using TOA for tangent. So TOA helps remind us that the equation for tangent of an angle, in this case we don't know the angle, but we're going to write theta there, is equal to opposite over adjacent, 7.7 over 14. Now 7.7 over 14, we can definitely put that into our calculator. That's a number. But how do we figure out what theta is here? We want to think about getting rid of this tangent function in front of theta. And there's an interesting inverse function that is the opposite of tangent. It is written like so, tangent, and it looks like it has a little exponent to the -1 power. But that's not really an exponent. That's just saying that it's the inverse of tangent. So we're going to take inverse tangent of both sides of this equation here. So inverse tangent of the left side of the equation and inverse tangent of the right side of the equation. And this actually cancels the tangent on the left-hand side to leave us with just theta. Theta is going to be equal to inverse tangent of 7.7 over 14. Now, how do we actually do this in a calculator? I would encourage you to go to desmos.com/scientific to find this specific function. Now, there is this button on some phones and definitely some other scientific and graphing calculators. But this is a free one that you can use online. So again, desmos.com/scientific. And the inverse tangent function button is actually under this Func tab right here. And then we can see that inverse tangent is located right there. And so on your keyboard, you can type 7.7 over 14, and that's going to give us the degrees of that angle there, 28.81, etc. We're going to go ahead and round that to the nearest tenth, 28.8 degrees, and you can always check your answer by looking at the diagram and seeing if that makes sense, and that seems like a reasonable answer for theta. Let's try one more example here. So we want to figure out what theta is, and we want to include an equation that has both pieces of information that they gave us. It looks like the 11.9 is the opposite side, and 14.2 is across from the 90-degree angle, so that is the hypotenuse. And so we want an equation that is going to use the opposite and the hypotenuse, referencing SOHCAHTOA here. And the one that uses those two sides is so. So we're going to use sine in this case. So sine of our angle, theta, is equal to opposite over hypotenuse, 11.9 over 14.2. And now, how do we isolate theta? How do we get rid of this sign in the front? We need to take inverse sine of both sides. Now, some people at this point just skip ahead and don't write all of this work because it's going to cancel, and we know it's going to be inverse sine of the right-hand side. So you can shorthand that too if you prefer, or if you like the satisfaction of seeing it cancel, that's fine too. So let's take a moment to find inverse sine of this fraction in that Desmos calculator. Again, we're going to click on the Func tab here, and we have inverse sine underneath sine there. And then on your keyboard, you can type the fraction. 11.9 over 14.2, and that's going to be 56.9 degrees when we round it to the nearest 10. And then comparing that to our diagram, that seems like a pretty reasonable measure of theta there. And for our last example, I just want to go over another type of problem that seems to trip people up a little bit. This is kind of reviewing back on what we did in some prior videos, but it's asking what is tangent of B? And so we have angle B right here. And recall that when we want tangent of B, we're just looking for that fraction of opposite over adjacent, since tangent is opposite over adjacent. But take a look here. The opposite side is labeled as 8, and the adjacent side is not labeled. So how do we figure out what the adjacent side is if it's not labeled? Well, thinking back to your right triangle toolkit, if you will, we now have SOHCAHTOA as a mnemonic to help us remember one thing that we can use to solve right triangles. But there's another equation that we learned way before this that also helps us with right triangles, and that is the Pythagorean Theorem. A squared plus b squared equals c squared. This is an equation you can use when you know about a couple side lengths in a right triangle and you want to figure out what the third side length is going to be. So if you recall, a squared plus b squared equals c squared means that your hypotenuse is going to go in for c, so that's our 10 here. I'll just go ahead and label this as A since we don't know what it is. And we can label 8 to be B. And now we're going to solve for A. 8 squared is 64, 10 squared is 100. We're going to subtract 64 from both sides. A squared is going to equal 36. And then we take the square root of both sides. The square root of 36 is 6 in this case, technically plus or minus 6, but we're going to use the positive version of that. So now we know that A is actually 6. So to figure out what tangent is, remember tangent is opposite over adjacent. And so that means tangent is going to be 8 over 6. And they do oftentimes like you to reduce your fraction as much as you can. So 8 over 6, we can divide each of those by 2, and so we'll get 4 over 3, and that is tangent of angle B.